Okay, so what we need to talk about next is how to get a Java application to talk to a SQL server. And this is where we left things last time. And what we said was that what the programmer can do is either write a program that combines the host language, Java, with some kind of embedded SQL, which means SQL statements that are sprinkled in with the Java code. So a standard Java compiler wouldn't be able to compile this program. But what we do is we run that through a preprocessor, which then converts the Java code with the extra SQL statements into just plain Java code with calls to some function calls that actually connect to the database. The programmer can also just simply write code that bypasses the embedded SQL and just writes Java code that makes those function calls directly. That's actually far more common. But once you have Java with function calls, then you can run it through a regular Java compiler. Of course, you need some kind of a library from your database to be able to connect. And the result of that is a regular program that talks to the database. So that's where we want to go. Now, it's a little bit of terminology here, but one kind of important phrase that we use in databases is call level interface. A lot of times it's just called the CLI. And that's just the functions that actually are provided by the database so that you can connect to it directly. And for Java, for example, it's just a bunch of Java classes that give access to the database servers. In this scenario, the SQL queries are simply strings. They're just Java strings, and you pass them to the functions. One bad side effect of that is that there is absolutely no syntax checking of the SQL queries. So when you bring up your code in, say, Eclipse, everything is syntax checked except for the SQL. So you won't know that there's a syntax error until you run the program. And that can be problematic. Now, embedded SQL, this is where you actually put in SQL code with the Java so that it's like a first-class object. The downside of that is that you need a specialized compiler to handle this extended language, or a preprocessor that understands the extra SQL stuff. But what's nice about this is that the SQL queries now are actually understood by your compilation toolchain, and so we can actually check them and make sure that that they're right and there's not a silly typo or something. So I want to introduce you to a concept that's pretty common in databases, and that's the, quote, impedance mismatch. Now, this is actually important when you're trying to program against a database, because chances are that you'll be programming in a procedural language, C++, Java, whatever. And procedural languages have a strict set of data types. Things like integers, strings, pointers, all those things that we're familiar with. And they're going to have loops, they're going to have if statements, they have assignment statements, they have functions, they have procedures, all those kinds of things. But one of the really important things about it is that they work with only one data at a time. So when I'm programming in Java, for example, I tend to think of having a finger that I can put in my code, and it's like, that's where I am, that's what I'm executing right now, is this statement. And then that statement moves to the next one, and then the next one, and then the next one. But I'm only working with one data at a time. If I need to work with n data items, I'm going to have to use a loop. That's the only choice that I have. Now, if you're programming something like MATLAB, for example, then you can actually process all of the elements of the array at once. But that's not very common in procedural languages that are mainstream. Databases, on the other hand, are designed to work on lots of items at the same time. For example, they might work on all rows in the table, or all rows for the state is equal to Wyoming, or something like that. Okay. Now, they do have some data types. Some of those are very highly specialized. For example, date and time, and there's other fancy stuff like bit vectors. But they're not always really super defined, at least not in the way that, say, an integer is in Java. I mean, in Java, an integer is 32 bits. In a database, int is whatever the database decides it wants it to be. So that's not a good thing. Now, the other thing, of course, is they have their own query language, like SQL. And for the most part, and we'll talk about exceptions later, but for the most part, that means just queries, select from where, not things like if statements and loops and all those things. So you're programming in two different languages, and the languages take a very different view of how to program. And so that's the impedance mismatch. How do we get these two things to talk to each other? And by the way, I want to point out that it's not just the fact that the models are different. It's that databases work on many items at a time because of efficiency. You don't want to read the first item, which is in some disk block, and then the second item, which is in a different disk block, then just keep going like that without actually thinking about reusing as much as possible each disk I/O, so that you get a lot of tuples processed for each disk I/O. So the reason that databases think of the world the way they do is really for efficiency. And if we can't get that efficiency when we connect to it from a procedural language, then we would never want to use a procedural language to talk to a database, which is ridiculous, right? So this is the problem that needs to be solved. Now, one way to solve it is with embedded SQL, okay? And that's why embedded SQL was so popular. So here's what embedded SQL looks like. We have a way to include SQL commands in C, and the C and the SQL actually communicate via shared variables. So what you see here is at the top of the program, you have a declaration section where you put some variables that will be visible both to the SQL and to the C code. In particular, I want you to see studio name and precedent net worth, okay? Those are two variables that are C variables. So notice that studio name is an array of 50 characters. And because of the trailing null, you can put up to 49 characters in that. And we also have the precedent net worth, which is just a regular 32-bit integer. Now, outside of that declaration section, you see regular C code. This is a strcpy command, which will just put the string Lucasfilm into studio name. And then here's some more SQL. And what we're going to do is run a select query and look up the net worth of the precedent of the studio, whose name is studio name. You and I can read the code, so we see that it's Lucasfilm, but it could have been anything else that was placed in there. And then the result, that net worth, is actually stored in the press net worth variable, which is a C variable. So that's how the SQL and the C actually work hand in hand. And you kind of bypass a lot of those problems we talked about earlier. The last statement is just a printf. That's just regular C code that is outputting the results. Now, let's look at that in a little bit more detail. So all of the SQL blocks are introduced via the keyword exec SQL. Okay, so we have exec SQL, and then it's either a single statement or a begin end block. So here we have exec SQL begin declare section, and 5 lines down or 4 lines down is exec SQL end declare section. Okay, inside of that, what you see is just regular C code. They're just variables using the exact C SQL syntax, but because they're inside that begin declare section, the preprocessor that does all the SQL handling knows about those variables and realizes that it can pass them between C and SQL. Okay, over in the SQL section, those variables will have a colon in front of it. Again, that's just to help the preprocessor know where the variables are being used. Okay. You may have wondered about that third variable, SQL state. That's a bit of magic, okay? What we saw is that the input was, I'm sorry, I forget the name of it. Let's look at it. The input was studio name, and the output of the query was press net worth. What SQL state is just a way of getting a status from the SQL side over to the C side, so that the C program knows what happened over on the SQL end. For example, this is how it would know that there is an error, okay, like a syntax error, all right? All of these codes are actually, quote, standard in the ANSI standard, and they are 5-character strings. They look like numbers, but they're actually strings, okay? So In C, we have to declare that as an array of 6 characters because strings in C are terminated with a null. So 5 characters for the actual code and 1 character for that special null. Now here are some of the codes, the SQL state codes that you may want to know. All zeros means no error, everything went well. 02000 means no more answers, okay? So if you run a query and there are 0 answers, SQL state will be 02000. But if you run a query and there are answers, then you can get the answers one at a time. When you run out, that will say, SQL state will say 02000. Okay? Now, that worked pretty well in the last example, because the query was designed to return only 1 row, okay? It gets more complicated when we want to try to look at all the rows, or many of the rows. So here we may want to look at all the movies made by Lucasfilm. Again, this is part of the impedance mismatch, because the database wants to give us all the results all at once, and the C code can only handle it one at a time, okay? If we were to solve this problem today, then we might be tempted, for example, to return a collection of results. And I'm using collection here as in Java util collection. So I'm thinking in terms of a list of records or a set of records, something like that. Okay, that actually is pretty. It's a pretty seductive idea. It makes the code so much easier because that list is just a Java object. The only problem with that is what happens when the number of rows is so large that you really don't want to store that in a Java object. There's just not enough memory to do it. Okay, so that's it sounds like a good idea, and sometimes you can use it. Okay, and for example, Hibernate actually does just that if you ask it to, but you still have to make sure that you're not getting too many rows returned. Okay, now to avoid the problem of too many rows, a real modern solution might actually not return the entire list, but instead returns an iterator over the list. So what an iterator has is he has a current index, right, so that he knows where it's at, and he can tell you, is it at the end or not? And if it's not at the end, then you can say, okay, so give me the next element. And he can just return the next element all the time, and nobody needs to actually know where that next element is coming from. It just returns it. Excuse me. So one possibility is that we actually load all the results into main memory and then return them one at a time. This is just like getting a Java list and then walking through the Java list. But what's better about this solution is that that's just one thing that it could do. The developers are free to do something much more complicated. So, for example, something that would be more complicated, but actually not any better, but something that would be more complicated is that every time you call next, it goes out to the database and says, okay, so get me the next row. That actually might be really slow. But you could go to the database and say, get me the next 100 rows, and then feed those rows from memory. When we get to row number 100, and you say next, then it goes out and gets the next set of 100, and so on. So that's actually a really super good solution. It kind of solves all the problems. And that's the way we would do it if we were starting from scratch today. But remember that this technology goes back several decades. So no, we're not. That's just not the way it was done. Instead, what we did was we had the same concept of iterator. It was actually developed in databases way before it was developed in object-oriented languages. But they didn't call it iterator. They called it cursor. Okay, so that's what a cursor is. A cursor is just a quote iterator that lets you step through all the rows in your result, and it lets you know when you run out of rows, and as long as you have a next row, it'll return that to you. Okay, so let's go ahead and use it. And again, this is the embedded SQL solution. So this is how we do it. The first step is we have to declare the cursor, and in many ways, what that really means is you're saying this is a cursor for that query. So you specify your query, which is any kind of select from, and then you open a cursor for it. Okay, I'm sorry, you declare the cursor for it. Now, later, we'll go ahead and open the cursor. Think of that as actually sending the query to the database. Okay, when you open it, that is the time that your code connects to the database and says, hey, I'm interested in executing this query. That sets up the data structure so that we know which is the first row, which is the last row, and it actually knows where it is in this whole scheme. Okay, so they will fetch the rows, and when we fetch the row, we just get one row's worth of data at a time. We fetch and we fetch and we fetch and we fetch until we're done fetching. We're done fetching might actually mean SQL state has the value 02000, which is no more rows, right? So when we're done fetching, we say close. I want to emphasize this a lot, okay? We close the cursor when we're finished. If you don't, then you're still leaving some resources in the database that are trying to handle that open cursor. And that will be a disaster because the database will get bogged down and it won't be able to service everyone. Okay, so let's do an example here. We have a declaration section that shows us the shared variables, a certificate number, a movie title, the year that it came out, and of course SQL state, because that's how we know what's happening. And we'll go here and now we'll declare a cursor. Okay, this is the section where we declare it. The name of the cursor is C_movies, right? So we're declaring C_movies, and we say that this is a cursor for, and provide the query. So our query is select title year from movies for precedent. Certificate number is :cert number. Notice that that :cert number is the connection to the declaration section, the certificate number, which is a C variable. And we're going to order that by year so that we see the we see all of the movies that were actually produced by this one person. Okay, so next step, the very first line there at the top, we open the cursor, so we have a connection now to the database, and then inside this loop, we execute SQL fetch. SQL fetch grabs the next line or the next row from our results. And you have to say from what? Of course, it's the cursor. That's how we identify the query. And where would you like us to store those results? And we say into title and year. Now go back to the query here, and you'll notice that that is select title year. There's two things, a string and an integer. And then we fetch it into and :title :year. Those are the C variables where we want to store the results. Okay. When that happens, when that exec SQL fetch statement is executed, it also sets the magic variable SQL state, because we said we're interested in that. And so we can actually check that magic variable and see if it has 02000, which means no more rows. And if in fact that is SQL state, then we break out of this loop. Otherwise, we'll just print the year and the title. So that's kind of how we show all the results. And because we're good programmers, then at the end of the for loop, we immediately close the cursor because we no longer need it. One thing I'd like to tell you, I actually feel very uncomfortable doing this, but it is very convenient sometimes. And that is that as you're reading the rows, you can actually modify them at the same time. Okay. Now keep in mind that you can always modify rows by executing the SQL update command. Okay. There's nothing wrong with that, and in fact, it's what I prefer to do. But occasionally, it's just so convenient. I'm reading a row, and immediately I make the decision, oh, I should set this field to true. I don't have to issue another query. I can just simply say, oh, set the field to true right here in this row. The way that's done is by executing a query, and the condition of the query is where and simply current of and then the cursor. So let's look at this example. We declare a cursor that goes through all the employees, gets the employee ID, their rating, which is how good they are, and the salary that they're making. So we get each row. Notice that our query has three things in the selection: employee ID, rating, and salary. And we place those into ID, rating, salary, which would be in the common declare section, although it's not listed here. We check for SQL state. If we're done, if we've seen all the employees, then we get out of this loop and we'll immediately close. But now check out the if statement that's inside of that. if the rating is greater than or equal to 9, then this particular employee is a really good employee. So let's execute a SQL statement that will update his or her salary and add 10% to it. So that is what that exec SQL update employees, the first one, does. And notice the condition where current of C employees. That's just saying where is the current row, right? Weird syntax, but that's what it means. On the other hand, if the employee has a rating that's less than or equal to 2, then we're stuck with a really bad employee. So rather than giving them a 10% raise, we're just going to delete them from the employees table. Presumably that fires them as well, although not everything is just a database. Okay. Now, everything we've done up to this point, you can actually read the code, the C code, and you can find the SQL code that is sprinkled in between and actually go, yeah, you know, there it is. That's the reason that the toolchain can actually extract that SQL code and check it to make sure that it's syntactically valid. Okay? But every once in a while, what we do is we actually build the query on the fly. So for example, this is a case where we say our query is, and notice that we're putting it on a string because we're going to manipulate it. So the query is select star from employees where rating is greater than or equal to 10. And then we append to that query, oh, and the location is in the United States. And then we append to that query, oh, and the last name should contain the substring Jones. Okay? So you could do this. And if you actually find this particular sequence of code in a, you know, I mean, this particular lines in some code, that is just sad, okay? Because we could have simply had like one string that had it all. There's no reason to build the string dynamically, okay? So what I'm going to tell you is that you should always avoid dynamic SQL, okay? And I'll repeat it. You should avoid dynamic SQL. I will say that, that there are times when you actually want to do it. And the best example of that is, let's say that you have a form that does an advanced search. So the basic search is just a text field where you type in your search keywords and hit return, right? But maybe you allow users to hit an advanced search and you say, oh, but then you can pick the category. Let's say we're talking about books, so you want to pick the author and the subject and all sorts of different forms. If you offer that, then you may want to build your SQL dynamically so that you can see, depending on what the user clicked, then you build a query that reflects just those choices, okay? So that's the reason that sometimes you can't avoid dynamic SQL. But if you can, you should. And one special case where I've seen people actually do dynamic SQL shamelessly, okay, is when the only thing that's different is a constant or a variable. So in here, in this particular query, we said for rating is greater than or equal to 10. Well, maybe you want rating greater than or equal to 8 instead of 10, right? Okay, if that's the case, you do not use dynamic SQL. What you use is a variable. So you can say rating is greater than or equal to :min rating. And that works better. Same goes for location. Maybe you want to put location equals France. So it should be quote FR quote instead of quote US quote. Make that a C string and say where location equals :country or whatever the name of the string is. But if all you're doing is you're changing a parameter, there's no excuse to swap to dynamic SQL. You should use static SQL unless absolutely necessary that you swap to dynamic. And like I said, the only case where that happens is when you're providing a GUI that is so powerful that you need to generate the SQL code differently depending on what the user picked. Right? So, okay, so let's take a look at some cursor usage here. And this is a dynamic SQL approach. Okay, so let's start with our declaration section. And in here we have our certificate number, which is our shared between C and SQL. And then we also have the query. Okay, and notice that the query is just a C-style query. Okay, if you're running this at home, C does not actually like it when you break a string with a new line, but that's easy to fix. Just put a backslash at the end of it. Okay, so nothing I'm worried about. Just there's our query. Okay, And notice that it uses cert number. Right? So it's just like any of the queries we've seen before. But now what we'll do is we say we will prepare SQL query from query. Okay. So what we're doing is we're declaring a query. This is a dynamic SQL query. And we have to say where it's coming from. Where exactly is the string that this query is tied into? And so we give that and realize that has to be a C variable. Otherwise, I couldn't build it dynamically. You know, I can only manipulate C types in my program. And it has to be available to the SQL side. So it has to be in that shared declaration section. Okay. All right. So now that we have the query, now we can create a cursor, just like before. Declare the cursor for some query. The only difference is that our queries, instead of being a select title year from movies right there as a literal, as a bunch of keywords, is actually this weird object, which is an internal representation of a query that was prepared earlier, right? The preparation, you can think of that as parsing the query. Okay, so now that we build it, we can say our certificate number, which is 12345, and we can open the query just like before, okay? I wanted to emphasize here the fact that when we open the queries, when we look at the certificate number that's in the C code, right? Everything up to that point is just using generic parameters. But once we open the query, then we have to have all of the parameters with actual values that we can go against the database. So the open query actually sends the query to our database, and we hop in the same loop as before, fetch from the cursor into some shared variables. Are we finished? Yes. Break from the loop? No. Print the row, and then do it all over again. And I'll emphasize one more time, we close the cursor at the end of the for loop. Okay, I want to show you just kind of a shorthand notation here. This is what we did before. We said where the precedent certificate number is equal to cert number, okay, and that was fine. In this case, what we're going to say is where the precedent certificate number is question mark. And the question mark is like a special parameter. What we're saying when we use a question mark there as a token, meaning in place of a constant, what we're saying is when we execute this query, we will provide you with the actual literal constant that should be going there. Okay? So here, where we say exec SQL open, we say exec open C query using this certificate number. Okay? So that's an alternative to actually hard coding cert number in the query. Personally, I like having the cert number better simply because if I have more than one parameter, then I would have to say using cert number, comma, the second one. And then you have to remember the order in which those parameters appear. If you use the actual shared variable names, then you don't have to worry about the order. It just gets taken care of for you. But this is actually pretty popular, so I mention it here. Okay, so that's really all that I want to cover today, and that is the C side for handling embedded SQL. Okay, we're actually not going to do embedded SQL programming in the class, so I'm going to leave it there and move on. Our next topic is going to be stored procedures, and this is actually a little bits of code that are stored in the database so that you can execute them from your C code. And rather than executing a query such as select from where, it will do, as you'll see, fairly complex code on the database in your behalf. And by fairly complex, what I mean is that it can do 10 different queries and use the output of all of them and combine them. So you can write your application with a large chunk of it being in the database. So we're going to go ahead and look at that on our next class. I'll see you then. Bye-bye.